Hello, I welcome you all. The problem reads, if the force is 10 S, where S is in meters, and the contact surface between the block and the ground is smooth, meaning no friction, determine the power of the force when the displacement is 5 meters. When the displacement is 0 meters, the 20 kg block is moving at the initial velocity or initial speed of 1 meter per second. Okay, this problem is coming from the Engineering Mechanics and Dynamics F14th edition by R.C. Hibbeler. So quickly, let's draw the free body diagram. So we have the weight acting through the center of gravity, and we have the normal force like so. So this is the normal force, and this is the weight. So we've been given the displacement that it has covered, and we do have motion in this direction like so. This is our AX. Alright, so it has covered 5 meters, and the question is to determine, we know that power itself is the rate at which energy is released. Alright, so power is equal to the work done divided by time, and this is just equal to FD, of course, cosine of the angle between the force and displacement divided by time, and then this becomes F cosine theta times velocity, right? Because this is some speed, right? Great. So we need the final speed there. Then with this particular force, then we are able to find the power, which is the rate at which energy is released to this particular object. So of course, you can find the final speed by using the equations of motion and kinematics, or you can use the work energy principle, right? If you want to. So we just go with kinematics. So just say summation of forces. Let's say we find the acceleration, and once we have the acceleration, find the velocity, and then find the power. So summation of forces in the x direction is just equal to this, okay, max, and we have 10s equal to max, right? Let me just call it f, right? And our ax is just equal to f divided by m, and this is equal to 10s divided by m, and m is 20. Therefore our acceleration is just equal to 0.5 s. Okay, now let's find the velocity. Final velocity, we can find the final velocity by using this equation. You can use this equation. You know where this equation comes from. Comes from v ds dt a dv dt, making dt subject to a formula. Then we have that equation, right? So we want to integrate this from s naught to s, v naught to v, where our s is equal to 5, our s naught is equal to 0, our v naught is equal to 1, and our a is just equal to ax, which is equal to 0.5 s. Right, so therefore, using this equation here, plugging in all the values, we have the following. So we are integrating this from 0 to 5. The acceleration is 0.5 s, and we have a ds there. Integrating this from 1 to b and b to b. Then we have a 0.5 s squared divided by 2. That is evaluating this from 0 to 5. This is equal to v squared divided by 2. Okay, and evaluating this from 1 to b. Of course, these are as constant, they can go. So we'll have a v squared is just equal to 0.5 by 5 squared, and then plus 1 squared, which is just a 1, right? Okay, because it was negative the other side, right? So then we just square both sides. We square both sides, right? And once we do so, then we'll have our v as just equal to just 0.5 by 5 squared plus 1 square root of that. We have a 3.67 meters per second, right? Okay, so once we have that, then let's move on to the next stage, which is working out the power. So we said power is just equal to the force cosine theta times the velocity. Alright, and our cosine, our theta there, our theta is just equal to 0 degrees, and therefore cos theta or cos 0 is just equal to 1. And then our v is equal to 3.67. Okay, right, that is 3.67, and our f is just equal to 10s, and s is equal to 5, and therefore our power is just going to be equal to 10 times 5 times 3.67. So power is just equal to 10 by 5 times 3.67, and this gives us a 183.5 watts. Right, I think this is about it. We have found the power of the force when the displacement is 5 meters and the block is moving at an initial velocity of 1 meter per second. I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and see you in my next screencast.